Hi, welcome back to Moose and Chemistry. This is Electron Configuration of Carbon lesson. Okay, carbon is element 6 on the periodic table, so we're going to write down a 6 here, and its AMU, or mass number, is 12. So that means carbon has 6 protons. To be electrically neutral, it'd have to have 6 electrons. Now, how do we find the number of neutrons? Well, like in my other lessons, we simply go AMU minus protons equals the number of neutrons. So we have 12 minus 6 equals 6 neutrons. Okay, so we're going to put a 6 there. All right, now we're going to do our electron configuration. But before we do that, remember that S will hold a max of 2 electrons, P can hold a max of 6 electrons, D can hold a max of 10 electrons, and F can hold a max of 14 electrons. We're also going to start off on the diagonal rule, and we'll follow these orange arrows down in that order until we end up with no more electrons. So we have 6 electrons to begin. So we go 1s2, and we're going to go down the next slide here, 2s2. Okay, so we've used up 4 electrons. So we come back up here, we're going to hit 2p next, and we're going to have 2p2. All right, so that makes a total of 6 electrons. Okay, that's pretty snarly. Let's look at our orbital notation in Hunter. Now remember that 1s, or s in general, holds only 2 electrons, so up arrow and down arrow, right? And 2s is going to be an up arrow and then a down arrow. Now we're going to have 2px, 2py, and of course 2pz. Now, do we have to have all those spaces because we only have 2 electrons? The answer is yes, because remember that electrons can not only jump suborbits when they get excited, but they can actually go up an orbit or even more. So let's put our arrows in, up arrow, because Hun says we have to put in 1 up arrow in every suborbit until we start the down arrows. Okay, so that's our orbital notation. Oh, great. Noble gas notation. All right, carbon does have a noble gas notation. The noble gas that's nearest to carbon before it, of course, is helium. So there's helium. And then we're going to put in our valence shell, 2s2, 2p2. Remember that the valence shell right here is the last shell. That's important to remember. Okay, our quantum numbers. Right? So we have quantum numbers N, L, M, and S. And remember that no 2 elements can have the same set of quantum numbers. That's the Pauli exclusionary principle. All right, well, what period is carbon in? Carbon in happens to be in the 2nd energy level, so our 2 goes right there. Carbon is also in the p block, right? So the p value is going to be 1. And since it's in the p block, it can either be -1, 0, 1, but carbon is the 2nd element, so it's going to be a 0. So it's going to be a 0 there. And let's look at our last arrow. Our last arrow right there is going up, right? So that's going to tell us that it's going to be 1/2 positive. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moose and Chemistry.